Welcome back. So, in the last module what we have seen is the effect of loading, right. If you remember what we have done, we have connected the potential divider to the inverting amplifier and we saw that the expected output was different than the experimental output. So, let us see if we connect the potential divider circuit to a non inverting amplifier. In this particular case what will be the output and can we still see the loading effect or not, alright. So, for that if you come to the screen, right, this is again the aim is same, but there is a third part of the same aim which is to study the effect of loading. So, here as you see this is same circuit which is potential divider and this is your non inverting amplifier. Non-inverting amplifier, we have already seen what is non-inverting amplifier, we have already seen how you can use non-inverting amplifier in your experiment, right. So, you apply a voltage to the non-inverting terminal of the non-inverting amplifier through the potential divider circuit, right, and you measure the output V out 3. So, what is that? Connect V out 1 to V 3 as shown in figure. So, let me just clear this one. V out 1 is connected to V 3 as shown in figure, alright. Apply 2 volts DC for power supply at V 1. So, here instead of 5 volts we are applying 2 volts DC, alright. Observe and note down the output voltage V out 3, we have to measure V out 3. That means that if I apply 2 volts, what is my V out 3? I have to measure, alright. Compare the observed output voltage V out 3 with the expected theoretical value, alright. Now, what we have seen? We have seen non inverting amplifier. In non inverting amplifier, what is the gain? The gain of the non inverting amplifier is given by 1 plus Rf by R1, right. This is the gain. So, here what is R1? Rf is your 1 kilo ohm, R1 or Rin is 1 kilo ohm. So, if both is 1, that means that 1 plus 1 by 1, this is 1 plus 1, this is equals to 2. So, my gain is 2, easy, very easy to understand the gain of the non inverting amplifier. So, I have a gain of 2, right. That means, if I apply 2 volts, my expected output should be 2 volts across R1 and R2. So, this is 1 volt, by gain of 2, 1 volt into 2. So, output will be 2 volts, right. So, my expected output at V3 is 2 volts, right. If I apply here 4 volts, right. So, if I apply 4 volts, my V out would be 2 volts, 2 into 2, 2 volts into 2, 2 is your gain, this is your gain, this is V 4 volts, right. Now, this is non inverting amplifier, that is why I am not writing minus. Last circuit if you remember, it was inverting amplifier, then we have to use negative sign because of phase shift. So, in this particular case let us see if I apply 2 volts to the potential divider circuit and if I measure the voltage output at the end of the non inverting amplifier. So, if I apply 2 volts at the potential divider circuit as an input and if I measure the output at a non inverting output of the amplifier, right. So, what is the output? And let us consider the case which I have written on the screen, which is 2 volts and 4 volts and let us see what is the experimental output and compare with the theoretical output, alright. So, let us see and let us focus on the breadboard once again. We have Suman with us to help us. So, he is going to apply 2 volts across the potential divider circuit. He is applying 2 volts. As you can see on the DC power supply, we can see 2 volts which is given to the potential divider circuit, which is same like last time if you remember, right. This is a potential divider circuit which is this one and we have applied 2 volts across it, 2 volts across it. This is a potential divider circuit where I applied 2 volts, and then yellow color wire is the output. Is the output is a voltage across resistor R2. All right. So, let us see what is the value of resistor R2, voltage across R2. Voltage across R2 is 1.009 volts. Voltage across R2 is 1.009 volts. This voltage we are applying to the non inverting amplifier. So, what let us see what is the output at the non inverting amplifier. Output of the non inverting amplifier. The output of the non inverting amplifier, when we apply a voltage or connect the output of the potential divider, is 2.017 volts. 2.017 volts. That means that when he applied a input of 2 volts across the potential divider, 2 volts he applied, he found that the output, this one was 1.00 some volts, and the output V3 was 2 sorry, was close to 2.017 volts, 2.017 volts, which is extremely close to 2 volts, which is extremely close to 2 volts. Here we are not getting any loading effect. We are not getting any loading effect. Let us take another example in which we are applying 4 volts as input. All right, 4 volts at the input of the potential divider or across the potential divider, 4 volts across the potential divider, and when we apply 4 volts across potential divider, the output of the potential divider will show us the voltage. This is 4 volts at the across the potential divider. What is the output at the resistor R2? 2.008 volts, 2.008 volts. So, let me write down here on the screen 2.008 volts. Very good. Let us measure V out 3, which is here, V out 3. So, let us see what is V out 3. V out 3. 3.99 volts, 3.99 volts. So, let us write down here on the screen 3.99 volts. Again see this, right. That means that what we are seeing, what we are looking at, we have connected the V out 1 to V 3, then we have applied 2 volts, then we have compared the theoretical and expected value. What we see is, it will be seen that V out 3 shows better compliance with expected output as compared to V out 2. So, the point here is that if I go and integrate my non inverting amplifier with the potential divider as the circuit, instead of using inverting amplifier with the potential divider as a circuit, then I would see that the loading effect in the case of non inverting amplifier would be less, or will be extremely less or negligible compared to the inverting amplifier. In case of inverting amplifier, we can see that the expected output was 4 volts or 2 volts or 10 volts, and the experimental output was half of it or 1/4 of it. That was because of the loading effect, right. But here, in case of this particular experiment, what we see is, if you use non inverting amplifier, the loading effect is not there. Loading effect is not there. So, guys, you have to understand now that if you want to remove the loading effect, what kind of amplifier you have to use, right. And if I use inverting amplifier, I will have a loading effect. If I use non inverting amplifier, I will not have loading effect. Okay. So, now again, why we took this example? Because a potential divider, we have said initially that one of the resistors of the potential divider you consider as a sensor, right. You consider one of the resistor of the potential divider as a sensor. And which kind of sensor? It can be any sensor that will show change in resistance, What kind of sensors are used that can show change in resistance? One is your strain gauge, another one is your temperature sensor, another one is your force sensor, another one it can be thermistor, right, which is temperature sensor, thermistor. Another can be for mass flow measurement. So, the point is, whenever you have to use a sensor which can show change in resistance, and if you put this sensor as a potential divider, then to reduce the loading effect you use the non inverting amplifier. That is the gist of this particular experiment. Now, we can understand that if I want to remove the loading effect from the sensor or the output of the sensor or output of the potential divider to the when I connect or interface the electronic module, for the I can use the non inverting amplifier. But what if I use a buffer between non inverting amplifier and between an inverting amplifier and a potential divider? So, will buffer solve the problem? Buffer is what? Voltage follower, right. We have seen voltage follower circuit in previous modules, right. So, how voltage follower circuit will work? I have also given you an example, right, by telling that election and then the mic and the speaker, right. So, at the speaker at the loudspeaker, the final amplifier that is generally used is common collector amplifier or voltage follower, at the input is common emitter amplifier or high impedance input impedance amplifiers. So, the point is, if I use the same voltage follower in the circuit where I have integrated the potential divider with the inverting amplifier in between, right, potential divider, inverting amplifier, buffer, voltage follower. So, if I integrate this, can I reduce the loading effect? Can I reduce the loading effect? So, in the next module, let us see this particular experiment where we will use a buffer between the inverting amplifier and the potential divider. Alright. So, I hope that in this particular module you got an idea of what is loading and how we can reduce the loading by using non inverting amplifier connected with the potential divider. So, I will see you in the next class. Thank you for your time, and I will see you in the next class with a new circuit where you will really understand how we can remove this loading effect. Thank you.